Now here's your time.
Can you hear me and see me?
Yeah, I can.
Okay. Hello, everyone, advisors and the chairman. I'm Mohamed Freishah from School of Geodesy and Geomatics, Wuhan University. And this is my presentation entitled Contribution to the Research of the Effects of Severe Non-Nuclear Anthropogenic Blasts, Beirut Port Blast, on the feature of the ionospheric total electron content behavior. This is the contents of tonight's presentation. Let's start with background and intro. Global Navigation Satellite System, or GNSS, providing positioning, navigation, and timing data to GNSS receiver. The ionospheric disturbance is crucial for communication and navigation system. Radio signal transmitted from satellite can be distorted by ionized plasma. And total electron content, TEC number, is the free number of electron in a unit area along the line of sight. And the unit is, TEC unit is 10 power 16 electron per meter square. The value of TEC depend on different parameters, such as geographic location and of the receiver and also satellite, the hour of the day, and the intensity of solar activity. The variation or disturbance in ionosphere can be categorized to regular variation, and this kind of variation can be pre-modeled in advance, in seasonally or annually or every 11 years. The other kind we focus on is irregular variation, and this kind of disturbance can't be pre-modeled right now, and this associated with different events like natural events, earthquake, tsunami, or typhoon, and also man-made events like rocket launches and the nuclear explosion. The crucial parameter can affect in the ionosphere is space weather indices, and we can conclude them in solar radiation and also the geomagnetic activity. As we can see, this is a parameter for the steady state or stable space weather for F10.7, about 19 for solar flux unit, and KB is less than 4, and DST for geomagnetic, it will be more than minus 20 nanotesla. In this kind, it will be in a steady state. Otherwise, it could be effect in the ionosphere. As I mentioned, solar and geomagnetic activity play a dominant role in dynamic regime of the ionosphere. However, acoustic gravity wave associated with severe explosion could transfer the energy from the lower to the upper atmosphere and can cause like or lithosphere atmosphere ionospheric coupling. For first time in 1958, it was the first ionospheric disturbance associated with above ground nuclear tests over Johnstone Island. And after that time in 1963, the above ground was banned, and then it's replaced with underground nuclear explosion. And in that time, it gave small atmospheric waves. In the beginning, they used the Doppler sounding for studying the ionospheric response to these events. In 1997, it was using GPS, total electron content, or TEC value derived from GPS data, to studying the New Mexico explosion. Recently, Park in 2011 and Zhang Xiaohong also studying in 2015. The studying the North Korean underground nuclear explosion happened in 2009. And they reported there are similar short-lived wave oscillation. However, there is sparse investigation are dealing with powerful chemical explosion. As it known, in last year in August, there is a massive explosion happened in Beirut or Lebanon. Because of more than 2,000 tons from ammonium nitrate, it's equivalent to 1,500 from TNT. To remember what happened in Beirut explosion, we can see a short video. This year, in last February and in September, respectively, Kondo and Jonah working on the same event for Beirut port blast, and but they also focused on the southern part response to the ionosphere, and they missing the other ionospheric in different areas. Also, they use the converted VTC is a projected value from a slant value, and maybe this is a reason for missing disturbance. And also they used polynomial fitting, and this kind of method to find the trending by using the trending based on polynomial fitting could filter out the lower frequency changes. While we have focused on the missing ionospheric response by using a superior approach based on slant TEC value. Also, we used the cosmic data to find the electron density profile to find if the blast can affect the higher atmosphere. The data we used, the course from Turkey, course station from Turkey, and IGS station around the area of interest. Also the cosmic satellite electron density profile, COSMIC-2, and also parameter for space weather from MNWeb website. The general methodology, after collecting GNSS data, we using carrier to code leveling to find the STC series. Carrier to code leveling can minimize the noise in the code, and also can retain the solve the ambiguity and retain the precision from the carrier. Then we're using Savitescu-Gloy smoothing failure to find as a trending method to find the ionospheric variation. After that, we use the space weather to check if there is some it is in stable state or not, and also cosmic data to verify our results. Results and discussion. As we can see here, space weather is KB index is less than 4, and the other parameter in a stable state, so it can be associated to the possible ionospheric disturbance we can find associated with this event. Here is the disturbance result over the south area. As we can see, the left figure is Savitescu-Gloy filter, and we can see the dashed line is the time of the event. After about 11 minutes, started to find the disturbance, and also, as we can see, over the other station, Ramo station is the IGS station, we can see almost synchronized together. And in the middle one, we can see the Morlet wavelet, and the period is about from 1 to 3 minutes for the disturbance. And the last one is the ground track for satellite, and this triangle is the board, and this circle indicates the maximum IPP point for disturbance. For the north part of the explosion, as we can see here, another 2 stations from course station in Turkey, but it delayed for some time, maybe because it a longer distance than this one. And also by calculating the velocity, we find that the disturbance to the north was slower than south, and this warranted by Jonah in 2018. Could be the velocity of ionospheric disturbance can travel with different velocities at different regions. Here we can see cosmic profile. As we can see here is a clear N-shaped wave structure. It's happened here. And the disturbance is traveled for about 30, is started or happened after 30 minutes from the time of event. And it takes about 20 minutes to travel from 300 kilometers to 575 kilometers. It indicates that the propagation speed of the wave was slowed down with the high altitude. The conclusion of the work: SCTEC slant total electron content disturbance resulted from a severe blast have been investigated. The GNSS STC variation have been observed from IGS over the Cyprus, and this is a new result. Israel is done already by Jonah and Kondo. Also, and of course, Turkey, this is a new result for the north of the event. On the day of the event in 217, according to the day of the year. STC disturbance coincide in space and time with Beirut explosion, and a meticulous observation of space weather parameter and synchronization in STC variation, indicating that ionospheric disturbance have been induced by the blast rather than any random event. Last, the electron density profile of COSMIC-2 satellite shows the ionosphere response to the blast at higher atmosphere. That's all, and thank you for your attention.
Thanks for the talk. I think this is a very nice talk. I think this is very solid research. The findings are well explained. I'm just wondering, are there any other works about the Beirut blast in this field? Are you the only ones studying the event using the changes of ionosphere?
For me, any another related to blast or another related to any event?
Yeah. So, are there any other researchers studying this event?
Yes, in this event I explained here. Can you see my screen?
Yeah, I can see your screen. So,
okay. As I mentioned, in this year there are two publications by Kondo and Jonah. This in February, and the other one it was in last September. And we try to cover the gap area because they only investigated the ionospheric response to the southern part from the event. And also they used only ground-based GNSS, and we used ground-based and GNSS space-based from COSMIC.
Okay, so you have multiple sources of data.
Yes, multiple sources and a new finding, because they only focus on the southern part, and they see they missing the disturbance in the north part. But we find it because they use the vertical TEC, and the vertical TEC is projected value, and as you know, using the mapping function, it could be
so
decrease
from
the precision. Yes, decrease the precision.
Okay, Thank you.
You're welcome.
Thank you.
Hello, Mohamed. Oh, hi,
Hello.
Yongxin.
Hi.
I'm just a little bit curious about the reason of why do we need this to research this? Because if there's a big like blast, so
Yeah.
definitely we can locate it from the other sources. So from this research, can we go? I mean, is there any other special reasons to use the atmosphere data to locate the blast? Or can we analyze the reason for the blast or go further in the future?
Actually, I have two plans, but as you mentioned, maybe because you already have the location of the blast, maybe you can from the ground track or different ground track, you can try to predict or find the location of the blast. But this method, I think it will be, because I read some articles during working on some things like this, but it was with earthquake. They're trying to find the epicenter for earthquake from the disturbance, but it will be maybe 2 or 3 degree different in the accuracy. So it's not easy to find because we didn't know the behavior of the disturbance. So we can try, no problem, we can try it. But also in my work, because the time is so limited, I just present some result. Also, we used seismic data to find the explosion and the effect of the explosion, and try to interpret this the explosion time with the disturbance happened, because as I mentioned, it's from lithosphere to atmosphere to ionosphere couplings. We should focus on data in the ground and in the atmosphere to find the kind of coupling for this.
Okay, yeah. Thanks, Mohamed.
Thanks, Professor Lee, and thanks, Professor Liang.